Good evening, all. Uh, I'm Amit Kumar Shinde. I welcome you all for this today's session. And in this session, I'm going to cover the stainless steel from the alloy steel part. We are going to discuss today the stainless steel and why this name is given as a stainless steel, or why these particular steels are termed as stainless steel only. What are their specific properties? How these stainless steels are classified in different types, and for each specific type we are going to discuss their composition properties and specific applications. Now one by one, we will start this session. I will start this session now. Okay, the the steels, stainless steels. Okay, first, why this name is given as stainless steel. Okay, as the name itself indicates, stainless. Okay, STAIN, stainless, means these steel does not corrode or do not any environmental condition. You cannot say any, but in usual environmental condition, these steels do not corrode. That's why they are termed as stainless steels. Okay, and why they do not corrode in the most usual environmental conditions? Because these steels have high corrosion resistance. Okay, these steels have high corrosion resistance, and hence they do not corrode in the most of usual environmental conditions. Due to this, they are called as stainless steel. Okay, now why this high corrosion resistance is present in the steels? This high corrosion resistance is due to the presence of chromium element. Okay, high amount of chromium element is present in these steels, which results in the high corrosion resistance. Now, how the addition of chromium or presence of chromium increases the corrosion resistance? Okay, how it will increase the corrosion resistance? Now, whenever these steels are exposed, or due to the environmental conditions, when these steels are exposed to the oxidizing environment, the chromium present in these steels comes in contact with the oxygen, and chromium gets oxidized. Okay, and due to the oxidation of this chromium, a thin film of chromium oxide is formed. Thin film of chromium oxide is formed. This thin film is hydrous in nature. This thin film of chromium oxide is hydrous in nature. It is passive, self-healing in character, and impervious to further attack. Okay, passive means it does not react, or it does not give any reaction to the environmental condition. And impervious means it is means any liquid or any other liquid does not cannot pass through this layer. Okay, that is the meaning of this impervious. Impervious is nothing but it is a protective layer. Other liquids or any other liquid cannot pass through that layer, this chromium oxide layer. Hence, whichever surface or whichever steel is there, it gets protected from the environmental conditions. Okay, this is the next slide. Now, in the first slide, I have discussed why these steels are termed as stainless steels, and what is the effect. These steels are termed as stainless steel because of their high corrosion resistance, and their high corrosion resistance is due to presence of chromium, which when comes in contact with the surrounding or environment, it get oxidized and form a thin, hydrous, passive, and impervious layer of chromium oxide. Now, the general composition of this stainless steel is explained in this next slide. Now, before explaining this general composition, the very important part of the stainless steel is percentage of the chromium. Okay, for getting sufficient amount of corrosion resistance to have stainless properties in the general environmental conditions, minimum amount of chromium present in that steel should be greater than 13%, and the chromium should present in the form of a solid solution only. Okay, to get the desired or required corrosion resistance, minimum amount of chromium should be greater than 13%, and it should, that chromium should present in the form of a solid solution only. Okay, now when the chromium is added into the steel, initially this chromium will combine with the carbon present in that steel, and it will form the respective carbide, and after forming reacting with the carbon, then it will go in the solid solution form. Okay, whatever amount of chromium is there, initially it will combine with the carbon and it will form the respective carbides, and after that the remaining amount of chromium, it will go in the solid solution form. Okay, and generally the amount of chromium which combines with the carbon is, okay, okay, now whichever amount of carbon is there, 17 times the amount of carbon, it will combine with the, okay, sorry, okay, sorry for disturbance. Okay, what I am, we will see the amount of chromium. Okay, whatever amount of chromium is there in the form of solid solution, then and then only it will increase the corrosion resistance. Then chromium in the solid solution form is calculated by using this formula. Chromium in the solid solution form is equal to total amount of chromium minus 17 times the percentage of carbon. Okay, because initially chromium will combine with the carbon to form its respective carbides. Okay, and in addition to the chromium, these steels contains other alloying elements like nickel, manganese, molybdenum, titanium, and tantalum. Okay, to improve certain properties as per the requirement of the applications. So in this second slide, what we have understood here, stain, whichever chromium is there, uh, it should be greater than 13%, and it should present in the form of solid solution only. Then and then only it will give you the sufficient corrosion resistance to have the stainless properties under the normal environmental conditions, or most general working environmental conditions. So after this, we will discuss some general properties of stainless steel. Generally, stainless steel have these properties. Any kind of stainless steel will have these common properties. Stainless steel will give you high corrosion resistance due to presence of chromium. Then it gives you high ductility and high formability. Then stainless steel shows good mechanical properties at low temperatures as well as at higher temperature ranges. Then stainless steel has high resistance to scaling and oxidation at a low temperature as well as elevated temperatures or higher temperature ranges. Then the stainless steels are having very good weldability, machinability, and formability also, because they are ductile or malleable in nature. Then stainless steel has very good creep resistance, and the last common properties in all kind of stainless steel is they shows excellent surface finish, or their appearance is very attractive. So these are some general properties of stainless steel. And these stainless steels are classified depending on their phases present in that steel, or depending on their specific properties and applications. Stainless steel are classified in four types as Group A, Group B, Group C, and uh, precipitation hardenable steels. Okay, if you search on the internet or other sources or in some books, one special stainless steel, that is duplex stainless steel, is also added. Means in general, in some books you can find 5 categories of stainless steels. In some books you can find 4 types. Okay, duplex steel is one extra type. I will explain it. Just I have not added that in this slide. Now, one by one, we will discuss all these 4 or 5 types of the stainless steels along with the composition properties and applications. Then we will start with the group A. This group A, this group A stainless steel, it is also known as Martensitic stainless steel. Why this is known as Martensitic stainless steel? First, I will explain it why it is termed as Martensitic stainless steel. Okay, now these steel, these group A steels shows austenitic phase at high temperatures. Okay, at high temperatures, austenite phase is there, and they are hardened by martensitic transformation. And due to this, at a room temperature condition, martensite phase is present in these stainless steels. Hence, they are termed as martensitic stainless steels. Okay, to understand what is the meaning of this martensite, bainite, or pearlite, I have added one separate video, transformation products of austenite. Uh, on that, with the help of YouTube links, you can go through that transformation products of austenite. It has 3 transformation products: pearlite, bainite, and martensite. And out of that 3, martensite is formed here. Okay, at higher temperature ranges, austenite phase is there, and hardening of the steel is done by getting martensite at room temperature. This is termed as martensitic transformation. Hardening done by martensitic transformation, and at room temperature conditions, martensite is there. Hence, these steels are termed as martensitic stainless steels. And as these martensite, which present at the room temperature, is hard in nature, and it has very high hardness, okay, high hardness and high corrosion wear resistance. These steels also shows the same properties that I have highlighted here. They are hard, wear resistant, corrosion resistant, and magnetic in nature. Okay. Why these wear resistance and hardness properties is there? Due to presence of this martensite. Okay. Now, related to the composition, this group includes, okay, plain iron, carbon, and chromium alloy. Okay. Okay. This group is iron carbon alloy with addition of chromium. Now here, the amount of chromium, depending on this percentage of chromium, we have classified this. Okay, we have classified stainless steel. In this group A or martensitic stainless steel, amount of chromium present in the form of solid solution is less than 13%. Okay, amount of chromium present in the form of a solid solution is less than 13%. Here I have highlighted it. Chromium in the form of solid solution, it is less than 13%. And its general composition, it contains chromium 12 to 18%, carbon 0.15 to 1.2%. Some other alloying elements may be there, and remaining or balance amount of iron will be there. Don't get confused in between chromium in the form of solid solution and total chromium. Okay, here you can see the total amount of chromium is 12 to 18%, but chromium in the form of solid solution is less than 13%. Okay, some amount of chromium, it will combine with the carbon and it forms its respective carbide. Hence, chromium in the form of solid solution is less here as compared to the total amount of chromium. And in this case, in group A or Martensitic stainless steel, chromium in the form of solid solution is less than 13%. Total chromium is 12 to 18%. Okay. And we have already discussed related to properties due to presence of martensite phase at room temperature. Is hard wear resistant and corrosion resistant and magnetic in nature. And due to these properties, this group A or martensitic stainless steel, these steels are used for manufacturing of springs, then different kinds of ball bearings, different kinds of walls, razor blade, then different types of cutting tools, then surgical instruments, then cutlery items. Okay, these are applications of these martensitic stainless steels. And generally, these martensitic stainless steel, these are designated by AISI 400 series. In competitive examination, they may ask you in the match the pairs. Okay, here they will, on one side they will give you martensitic stainless steel, ferritic stainless steel, austenitic stainless steel. And on the other side they will give you AISI 400, AISI 200, AISI 300, like this. You have to match the correct pair. Okay, for that, this group A or martensitic stainless steel, generally these are AISI 400 series designated by this series. Okay, then we will move towards the second type of stainless steel. Second type of stainless steel is group B, or it is also known as ferritic stainless steel. And these ferritic stainless steel are also designated by AISI 400 series. Now, first we will discuss related to the composition. This group B or ferritic stainless steel, these are iron, carbon, and chromium alloys. Okay, iron, carbon, and chromium alloys with amount of chromium in the solid solution form more than 13%. Okay, chromium in the form of a solid solution is equal to total amount of chromium minus 17 times the percentage of carbon. Okay, this much chromium will combine with carbon and it will form the respective carbides. And in this group B or ferritic stainless steel, chromium in the form of solid solution is more than 13%. And the general amount of chromium present is 13 to 27%, and carbon amount is less than 0.2%. Okay. Now here in this case, chromium to carbon ratio is more than group A steels. Okay. Group A steels, you can say that chromium to carbon ratio is more in group B as compared to group A steels. Now here one example I have added, this 430 steel, AISI 430 steel, which contains 14 to 18% chromium and carbon maximum up to 0.12%. General composition of this group B or ferritic stainless steel will be like this. These are iron, carbon, and chromium alloys with 13 to 27% chromium, carbon less than 0.2%. And out of total chromium present in the form of solid solution is more than 13% in case of this ferritic stainless steel. Now, why this group B steels are termed as ferritic stainless steel? They show, please refer this third point, they show only ferrite phase from room temperature to high temperature ranges. Only ferrite phase is present from room temperature to high temperature range. Due to this, they are termed as ferritic stainless steel. And as this ferrite phase is soft, malleable, and ductile in nature, these group B steels or ferritic stainless steel, they are soft, malleable, ductile in nature, and magnetic in nature. And they also have good formability good machinability. Along with that, they will show you good corrosion resistance due to presence of more chromium in the form of solid solution as compared to group A. This will show more corrosion resistance at low cost. So these are properties of group B or ferritic stainless steels, and due to these properties, the ferritic stainless steels, the ferritic stainless steels are used for manufacturing of vessels, different vessels, which we are using in the chemical and food industries, then manufacturing of different pressure vessels, different furnace parts, different kinds of heaters, heat exchangers, then juice carrying pipes in sugar industries, then architectural and automotive trims, then different kinds of restaurant equipment, pot, pans. Okay, all these are manufactured with the help of this ferritic stainless steels. Okay, different kinds of restaurant equipments, or if you observe your kitchen, in kitchen lots of steel utensils are there. Okay, that all are made from this ferritic stainless steel. Whichever pots, pans, or plates you are using made up of that steels are all made from this ferritic stainless steels. Okay. So these are ferritic stainless steels or group B steels. Then we will move towards the third type. Okay, we will now move towards the third type, and the third type. Okay, some question is there, that is some equipments are non-magnetic. Okay, because of other alloying elements, presence of other alloying elements. Okay, sometimes some kind of materials will be non-magnetic in nature. Okay, any other query is there, you can add that in the chat box. Okay, now we will move towards the third type, that is group C. This group C is also known as austenitic stainless steel. These are designated by AISI 200 and AISI 300 series. Now, why these steels are termed as austenitic stainless steel? Because in these steels, uh, austenite phase is present at room temperature. Okay, at room temperature, it shows austenite phase. Only austenite phase is there. Hence, these are termed as austenitic stainless steels. Now, related to their composition, okay, it contains this group C or austenitic stainless steel contains at least 24%. Okay, 24% of amount of chromium, nickel, and manganese. Combined amount is 24%. And out of this combined amount, minimum 18% chromium should be there. Okay, minimum 18% chromium is always there, with very low percentage of carbon. Carbon percentage is very low, and along with chromium, nickel, manganese. Okay, these other alloying elements are there. Two examples I have highlighted here: AISI 202 steel and AISI 302 steel. Okay, chromium is 17 to 19%, carbon maximum 0.15%, nickel 4 to 6%, manganese 7 to 10%. Okay, and amount of nitrogen is 0.25%. This is maximum amount, right? 0.25 is max. Then in case of AISI 302 steel, chromium is 17 to 19%, carbon maximum 0.15%, and 8 to 10% nickel. Now, in addition to these alloying elements, okay, chromium, nickel, manganese, you can add some other alloying elements like molybdenum to increase the corrosion resistance or acid resistance. Then you can add titanium, niobium, or tantalum to reduce the intergranular corrosion. And you can add sulfur or cesium to increase the machinability of these steels. Okay, to improve the machinability, these elements are added. Okay, depending on the required properties, to increase corrosion resistance or acid resistance, some elements we can add to reduce the intergranular corrosion. Okay, the corrosion which occurs in between the grains. Okay, that will be termed as intergranular corrosion. To reduce that, some elements may be added. To increase the machinability according to your need, you can add some elements. Okay, so the general properties of this group C or austenitic stainless steel will be like this: they are soft, malleable, and ductile in nature, but these are non-magnetic in nature. Their corrosion resistance, is highest among the group A, group B, and group C categories. That is, their corrosion resistance is superior to ferritic and martensitic stainless steels. Then already I have explained this. They show only austenite phase at room temperature. Hence, they are termed as austenitic stainless steel. Then they have low thermal conductivity and high coefficient of expansion. And then they have excellent cold forming characteristics and very good strength at higher temperature conditions also. Due to this properties, this group C or austenitic stainless steel are used for engine manifolds, manufacturing of engine manifolds. And these are used in food and chemical plants. These are used in the manufacturing of tubular exchangers, utensils, then wrist watches, sanitary fittings. All these are applications of group C or austenitic stainless steels. Last type of this stainless steels is precipitation hardenable stainless steels. Sorry. Okay, one more type is there, but I have added 4 types in the slides. When I will explain orally, I will explain it without that slide. Okay, the precipitation hardenable stainless steel. These steels contains elements like this molybdenum, niobium. Nb and Cb is same symbol. Okay, is same symbol for niobium only. Nb or Cb, molybdenum, This is niobium, titanium, aluminium, copper, nitrogen, in addition to the basic elements chromium and nickel. Example of this precipitation hardenable steels, I have added here two examples: AISI AM 350 and AISI AM 355. In this composition will be like this: carbon max 0.1%, manganese 0.8%, silicon 0.3%, chromium 17%, nickel 4%, molybdenum 2.75%, and nitrogen 0.1%. Similarly, you can go through the next composition also. Now, in this precipitation hardenable steel, these steels have higher strength, okay, due to the precipitation of complex compounds. Okay, precipitation of these whichever alloying elements are there, like nickel, aluminium, and other alloying elements are there. Their complex compounds are formed, and they are present in the form of precipitation. Okay, you can observe the separate particles when you observe it under the microscope. Separate precipitation of complex compound is there, and due to this precipitation of complex compounds, they give high strength at high temperature range, about 550 degrees Celsius. Okay, this is the property. Due to presence of precipitation of certain complex compounds, they have high strength up to a temperature of 550 degrees Celsius. And due to this characteristic, these precipitation hardenable stainless steels are used in aircraft and missile industries for manufacturing of skins, nibs, then bulkheads, and other structural components. The aircraft and missile industry, different components are manufactured with the help of this precipitation hardenable stainless steel, because they provide you high strength and high hardness along with the great corrosion resistance property, even at high temperature range up to 550 degrees Celsius, due to presence of precipitation of complex compounds of alloying elements. Okay. Due to this, these precipitation hardenable stainless steels are used in aircraft and missile industries. Okay. Now, in this way, we have completed these four types. One more extra type is there, that is duplex stainless steel. Now, this duplex stainless steel is nothing but it is the combination of two stainless steels, that is austenitic stainless steel and ferritic stainless steel. Okay, that is combination of group B and group C. Combination of 50% group B, 50% group C is termed as duplex stainless steel. Okay. Austenitic stainless steel and ferritic stainless steel in equal amount are termed as duplex stainless steel. And generally, this duplex stainless steel will be more stronger, and they will provide more corrosion resistance as compared to austenitic and ferritic stainless steel. And one practical example, I will, or composition of duplex stainless steel will be like this: is iron, carbon, and chromium alloy with chromium 21 to 27%. Okay, then nickel 1.3 to 8%, then copper 0.0 to 3%, and molybdenum 0.05 to 5%. Okay, this composition is a general composition I have collected from internet sources. Um, this will be termed as a duplex stainless steel. Now, as this duplex stainless steel have better corrosion resistance and better hardness and strength, these duplex stainless steels are used for manufacturing of the storage tanks for different kinds of chemicals, then transporting of different chemicals from one place to another place. It is used for manufacturing of different kinds of containers also for transporting the chemicals. Okay, these are duplex stainless steels. Okay, in this way, in this session, I have completed this part. Stainless steel. Okay, stainless steel. Why these steels are termed as stainless steel? Their specific properties. Then how these stainless steels are classified in different types as Martensitic stainless steel, then Ferritic stainless steel and Austenitic stainless steel, Precipitation Hardenable stainless steel, and Duplex stainless steel also. I have covered all these types along with their composition, properties, and applications. If any doubt or query is there, please mention that in the chat box or comment box. Thank you for attending this session. If you are okay, thank you for attending this session.